Welcome to episode 11 of RoboWeekly. Hi, Dan. How you doing? 11,
I'm doing
10,
11.
1. 11.
It goes to 11.
It goes to 11. Yeah, that's
Had to
kind of
be.
more. You know, that movie wasn't really that famous in England for some reason. Not as famous as just like Led Zeppelin was more famous here than it was there. But
I worked with a very successful record producer, and we watched that movie one night, and he was crying during the Japan scene.
Crying with laughter, I'm assuming.
Well, crying with just connection to the story. I mean, anybody who's been in the arts, in music or dance or startup, right?
That's right. That's right.
Right. Get your first eyeball.
I just want to let everybody know that in 2 weeks' time, it's going to be the big robot convention in Boston. We will be there in person, interviewing people, looking at stuff on the floor. So that will probably be episode, if this is 11, that will probably be 13 or 14. So that's
lucky
coming
13.
Up. Yeah, unlucky 13. But we've got some specific things to talk about this week. There hasn't really been anything in the space that we generally like to play in, which is the low-cost space, home cobot space. So we know that's a slow space, but so we're not focusing on that. But we are focusing on some significant announcements. The first one is from a company called Bow, B-O-W. And Bow, which I'm going to ask you to help me explain, is actually out of the University of Sheffield in the UK.
Okay.
And they basically say it's a spin-off from the University of Sheffield. They basically describe themselves as a platform to simplify robotic development. So that they're a hardware-agnostic software company, which we're starting to see a little bit of now. I wonder if you could tell me, if you could figure out exactly what it is that these guys see, what problem they seem to be solving, if any.
Sure, because we've seen this problem, and we've got our own solution, which may be similar, which is the sort of the de facto standard library that you use to run robots is called ROS, Robot Operating System, ROS 2.0, whatever. It's been around for a long time, and it's very, very geeky and a very steep learning curve. I mean, it's very powerful, but it's not something that a weekend warrior is going to spend 3 hours and get anything, worthwhile on it. So what they're probably doing, and I don't think they're the only ones that are thinking of this, is putting a sort of a nicer layer in front of this robot operating system. So that's like the robot operating system is like, the Linux kernel. Like, I don't recompile the Linux kernel to run, Office software, right? And you shouldn't have to go to ROS.
This is sitting on top of our.
Yeah.
This is sitting on top of ROS.
Think of there being like a hardware layer, a driver layer, and then an application layer, right? And some middleware, and then an application layer. This is at the application level.
Got it. And the thing I like about these guys, I have to say, is that they're actually. I did have to say there wasn't a lot of cheap, low-cost robots out there. These guys are actually selling and shipping a €6,000 robot for you to use their stuff on. So under the
quadruped or biped?
If you scroll down a little bit more, it actually shows you they're actually shipping a $6,000 quadruped. And I'm impressed with that. I like people that ship stuff. That's pretty cool. Yep. There you go. The SDK powering AI robots. I don't know.
Didn't some Chinese company come in with a $2,500 quadruped recently?
Is that one we talked about?
We can look that up later. Sure. No, it wasn't one we talked about.
Okay, so we've talked about Bow. You're basically telling us this is the application layer that's basically like apps and Windows and apps on.
Sure,
Unix.
But I'm very curious as to what's going on under the hood, because they still have to do all the ROS stuff. They have to do the machine learning stuff. That's all got to be somewhere. And there's got to be user accessibility to it. I imagine on the AI side, it probably looks a lot like ChatGPT or one of these, services from Claude or Google, an API. Although that's a little weird because it's a mobile robot. I'm not sure you want it to be dependent on a Wi-Fi link to Amazon in Seattle, to have your robot, get your
that's
pills.
Another question, not for this episode, but one of the questions is how important is it to do queries locally, and does one need access to Wi-Fi, to do it properly? And I think my quick answer to that, by the way, is that queries are getting, a query on an LLM is 50 times more expensive than a Google query, and if you can do it locally, it's going to be cheaper, because otherwise you're going to have to pay for it, quite frankly. And we know
what you might do is use the cloud one during development, because it's powerful and
training the model,
and you're not that concerned about the cost, because it gets folded into the
one-time thing,
amortized into the R&D budget. But then when you actually go out to people, either you provide your own endpoint, which is cheap, or you make it local. Right, those are your choices.
With one of these nanos,
or there's actually a hybrid. There's actually a hybrid solution, which is to have a base station in your house or apartment, and have
communicating
a separate,
have
Bluetooth or a separate Wi-Fi channel, so that you have the connectivity.
Yeah,
but these things. It'll be interesting to see how these things get dealt with.
I don't know if people have desktops and laptops and shit in their house anymore. Where's the CPU now?
It's going to be
your phone,
Fabian. It's going to be a 4x4 box that sits in a closet.
Right.
Like the Roku. It's just going to, the brains of the thing. I'm just saying they don't have to physically be on the robot. Taking up battery power. I was talking to Blake about this.
I'm just wondering out loud. Wondering out loud where that main CPU is going to be, because I don't see desktops in anyone's house anymore.
No, it's not going to be a desktop. It's going to be like a little. It's going to be some dongle that runs a full Linux operating system with GPU.
Yeah, it's going to basically run your house. Yeah,
right.
Let's move on to the second one, because I think you might recognize the second one. The reason I've actually put this one in is because you might recognize it.
Is this the one that our mutual friend Henrik worked on?
Yeah. So I've put this up here because they've announced that they are opening offices in New Jersey. This is Okibo from Japan.
You should explain what it does, because it's not obvious just looking at it.
So this machine does plastering, sanding, and painting of sheetrock.
Right, or drywall, right?
Drywall, correct. And they have just announced that it's done 1 million square feet in Europe. They've just announced their American office. As we know, the business model here is they say that it does the same job as 10 men, and they charge you, does 10 man hours of work, and they rent it to you for the equivalent of two man hours of cost of labor, something along those lines. But it works, and we've now seen it work.
RAAS, robot as a service.
Yeah, robot as a service. That's the model. And hey, it's called the Okibo. This one's called the EG7, and
but it's not a universal humanoid, right? It's a special purpose robot.
Special purpose robot
in that category.
Yeah,
but they got the market.
They got the market. They I got to tell you, as a real estate developer, I would have thought that one would have been a tough cookie to crack, tough nut to crack.
Well,
but they cracked it, so congratulations to them. Very impressive. I like people that do real things at this point.
Yep.
Let's move on to our third one. This is a collaboration between OpenMind and a company called Demo.
So is OpenMind related to OpenAI?
Yeah, I believe so.
Okay.
So what Demo have done here is robot to robot communication. So the concept here is that your robot at home is going to know when you're driving home or when your deliveries are going to be delivered, so that it goes to the door to meet them. Instead of it being upstairs, it's downstairs when it needs to be downstairs when you're bringing the groceries home, or I'm not quite sure what other examples it gave, but it's not only your personal robot talking to your car, but we all know about the refrigerator ordering new food. But this is basically instead of things, it's robots, actual robots, which has a definition, as we know, as something that acts in a certain way, talking to other robots. And this is the critical bit, without human intervention. So
here's how it should meet you at the door.
Yeah.
Sir, would you like me to serve you now? like a what do you call a wine guy?
Which guy?
The guy who serves you wine. Sommelier.
A butler. Oh, a sommelier, right.
Sommelier.
Yes. For those people who drink, yes, that would be the best way it could meet you. But I think the critical thing that it's actually, I'm not sure it is it's openmind.org and Demo. And the critical thing that they emphasize over and over again is without human intervention. So, this is now, we're now starting to get to a point where instead of it being Internet of Things, it's sort of Internet of Robots.
Right. But how does it go from without human intervention to without human authorization?
Well, I guess you better get that alignment all aligned first before you allow them to start driving.
Align before you sign.
Make the world better. Yeah, never hear the world dead. Okay, let's move forward to our next one, our last one for today, in fact. This one's called Neuro. I brought this up for two reasons. The first one is that they develop software that is car agnostic. So they don't care.
That's a Waymo car.
Maybe it is.
I think so.
Okay, but the point is this company Neuro. The reason Neuro is interesting is it's just raised the reason it's in the news this week is it's just raised $106 million in a Series E, giving it a post value of $6 billion. This is a software company only. Again, it's car agnostic, and it has two versions, the Neuro Driver and the Neuro Driver Assist. I have to tell you, I could not discern the difference between the Neuro Driver and the Neuro Driver Assist, but I would wager the second one costs more.
No. The assist is going to be less powerful. I mean, that's.
Oh, you think so?
I think they're using terminology that's like, full self-driving versus self-driving with some interaction with the driver.
So I don't know.
Tesla's been hung up at that phase.
So we've got Waymo that's been hugely successful. That's now I believe going to Tokyo. I think it said. And we've got other cars doing their own stuff, and here we have Neuro raised a ton of money and is clearly making the bet that
that every manufacturer
is not the way to go, which we agree with. And so I'd like you to comment on this particular one because it's raised so much money, and of course this brings us to our general conversation of today, which is obviously has complete relevance to our own company, which is where does the hardware stop and where does the software stop, the hardware start, and where is the role for a company that wants to be a software company, just like Neuro with a $6 billion post valuation?
Well, let me make a sort of a geeky point that's worth thinking about. In the olden days, back in the prehistoric days, we wrote software which was compiled to object code, which then ran on a computer, and you usually manipulated documents. So it was like, software, hardware, software, deep layer, and then application layer, like we were talking about with Bao. But when you talk about AI, you have a totally different infrastructure because you have software, but all the software is doing is training the neural network. And the neural network is, you could call it software or hardware. It's a huge amount of information that has to be stored somewhere and operated on in a certain way to affect the things you want the AI to do, right? So I mean, it's a little confusing even. I mean, we know hardware is hardware, right? It's stuff that rolls around, but I mean, it's got cameras that are going into vision models. I mean, the integration is extreme in a way that it wasn't before, and I think that's worth thinking about.
So we've looked at three of the four companies that we've talked about today: Bo, OpenMind, Demo, and Neuro, are all pure software plays.
Well, that's what their marketing people are saying. But what I'm trying to get at is, okay, they may not be forging metal and running 3D printers, but they are going to have to be dealing with low-level aspects of each of the cars they support. For instance, in the case of this one, I don't think it's just trivial to write robot agnostic software. I mean, in the communities that I hang out with, it's very much known that you can train 90% of a robot on sort of generic data, but then you need data on the exact robot you're really going to run on for that final 10%.
Right. Okay.
So I'm playing word games a little bit. So fine, it's all software.
I think it makes complete sense. I mean, and that's how they're going to make their money.
Yeah.
Because they're going to have to spend a ton of money customizing it for each particular car. I mean,
that's NRE, non-recoverable engineering. Yep.
Yeah. Okay. So and for a software company, I think you've almost sort of answered a little question here. For a software company to exist in this space right now, which three of these four companies are pitching themselves to be, not only are they coming up with software, but clearly they're having a service package as part of what they're doing.
Again, yes, and they also have to define. They have to carefully define the hardware that they claim they're going to run on, and probably
optimize for it.
Optimize for that. They can't optimize for 200 robots, only 3 of whom they're doing business with, right?
Right. So
that's my point.
Yeah.
So they may not be in the hardware business, but they're going to have to be very aware of the hardware they're running on.
So let me just ask you the final question is, if you are a software company in today's robot environment, what should you be focused on and what should you be doing? Are these companies focused on the right thing?
I think you should be focused on the bleeding edge of what large models can do, not large language models, but large vision models, large action models, multimodal. Like someone was asking me on Discord on another channel, because I said that this YouTube is okay, but he's not really doing VLM. He's not doing video language action. And the guy said, well, what do you mean? And I said, well, he trained the robot to take a golf ball and put it in a cup. It can't take a cup and put it on the golf ball. It can't take 2 golf balls. A vision action model that really works is going to be like, Freddie, could you please pick up the blue ball and put it where the red ball was yesterday? It's like real comprehension. So the integration of natural language, which is the huge breakthrough that started with GPT, and the thing that sort of makes us wonder about, their level of intelligence and sentience, is marry that natural language ability, like they've done with coding, with Python and JavaScript, to marry it to the real world. I'm talking about our sector now. So your software, but your software that is very, very aware of the hardware and the world that you live in, through simulation or just gathering enough data. They were able to do LLMs because the internet was trillions of bytes of verbal
data was there.
But we don't have that in 3D. We sort of have it in video a little bit. I was once called upon to scrape 1 million hours of video for a client that will not be named. But all these companies have scraped data from everywhere, but it's very hard to go from 2-dimensional like camera shots to 3D. And you don't necessarily have the information you really want, like that you get with the cameras on the wrists and things like that.
Right. I think it's going to open up a lot of very interesting avenues. Vision language action models, which are in vogue right now, probably won't be in vogue in 12 months' time.
Well, they may call them something else.
They may call them something else. They may have morphed in something, or they may have been, superseded by something. We don't know.
Right.
Anyway, I think this was very interesting. I think we're actually, in episode 11, we're starting to figure out with the world itself which way we're all going together. Certainly we now know things are, for a few years now, have been heading massively in the industrial direction, and that's where robots started, and certainly that's where people think that the scaling is going to come. But of course, we believe that there's going to be room in other cobot areas for them to exist with everyday human beings, and we believe that cost is going to come down to something that's affordable and useful.
Can I take advantage of your accent?
Yes, please. Yes.
So you're Nigel Tufnell, and you just said it goes to 11, and I'm Rob Reiner. I'm like, but couldn't you just say that 10 is what you're calling 11? And you say,
I don't know.
It goes to 11.
It goes to 11.
There you go.
It goes to 11.
Over and out.
Sorry. Okay, well, listen, thank you, everybody, for tuning in again. It's been really great. By the way, I'll be playing at the Gotham Comedy Club in New York on May the 4th. May the 4th be with you, 5:30 p.m. Anyway, thank you for...
knock 'em dead.
Thank you for watching episode 11. Bye, everyone.